Okay, algebra students, we're now ready for section 2 of chapter 6, where we're still working with systems of equations, but this time our method for solving them is going to be substitution. Notice the little diagram here where we replace one thing with the other thing and they must be equal. So substitution is using algebra to solve a system. If two values are equal, one can be substituted for the other. Okay, algebra students, in section 2 of chapter 6, we are still solving systems of equations, but now we're solving by a new method called substitution. That's when we're going to use algebra. Instead of graphing, we're going to use our algebra knowledge to solve the system of equations. If two values are equal, then one can be substituted for the other one. That's the definition of substitution, replacing one thing for another thing of equal value. For example, when you have 2 dimes and a nickel, whoops, that's supposed to be dimes, 2 dimes and a nickel, it's the same thing as a quarter. It's 25 cents. Okay, so that could be 25 pennies, or it can be 1 quarter. So all three of these are equal. 2 dimes and a nickel, 25 pennies, 1 quarter. You can substitute all of those for each other. So our situation is we have two variables. When we talk about a system of equations, we have an x and a y. So our game plan is to substitute in order to get only one variable. That's our goal, to have only one variable. So here's a little summary of solving by substitution. Step number 1, when necessary, you're going to solve at least one of the equations for one variable. So before I move to step 2, let's look down at this very first example that we have here. Y equals negative 4x plus 12. It's already solved. Y is already alone, one variable. So check, we've already taken care of step 1. It was done for us. Step 2, substitute the resulting expression from step 1 into the other equation to replace the variable, then solve the equation. So I'm going to, in this equation, substitute the y value that I found, or actually that was given to me in the first equation. So 2x plus, and in place of y, I am going to substitute negative 4x plus 12. This is what I have substituted, and that all equals 2. So 2x plus, and in place of y, negative 4x plus 12. Now we can combine our like terms, so a positive and a negative. I subtract and keep the sign of the larger value, which is, or the larger absolute value. So it's going to be negative 2x plus 12 equals 2. Subtract 12. And negative 2x equals negative 10. So guess what? X is going to be 5, a positive 5, because a negative makes a positive 5. All right, so let's review. Step number 1 was taken care of in the original problem where we isolated one of the variables. Step number 2 we took care of here where we substituted in place of the y that was in the second equation. We substituted the y value for the first equation. And now we're ready for step number 3. And step number 3 says substitute the value from step 2. Well, what was that value? That was x equals 5. So I'm going to take x equals 5 and I am going to enter it into either equation. It does not matter which equation. I'm going to pick this one, the first one, because it already has the y isolated. And y is what I'm looking for. I now know x. I need to find y to know the point where the two lines intersect. So in place of x, I'm going to substitute 5. And when I do that math, I get negative 20 plus 12. So y equals -8. So the point where the two lines are going to intersect is at the point 5, -8. So that is the solution to that system. All right, let's work number 2 together. Obeying our steps for solving, this one does not already have a variable isolated. So looking at the two equations, I'm not just going to dive into the first one. I'm going to study it to see which way can I get there the quickest, because I got better things to do than sit around working algebra problems. So I'm going to take this second equation and I'm going to add 2y to both sides. And right there I'll find out that x equals 2y minus 3. So I took the second equation this time and I isolated the x. It does not matter which variable you isolate. So there's step number 1. I have an x. So step number 2, I'm going to replace in the first equation 3x, and in place of x I'm going to substitute 2y minus 3. So there, in place of this x, I plugged in 2y minus 3 plus 5y equals 24. And don't forget to distribute the 3, because 2y minus 3 is one number, and that whole number is getting multiplied times 3. So now that becomes 6y minus 9 plus 5y equals 24. Combine your like terms, 11y minus 9 equals 24. Add 9. 11y equals 33. Divide by 11 and y equals 3. So step number 3, I'm going to take y equals 3 and I'm going to plug it into this new equation for x. X equals 2 times, and my new y is 3, and that's minus 3. So x equals 6 minus 3. Now where did I get this equation? I actually went back to the x that I solved for. In place of this y, I substituted 3. So now I have 6 minus 3, and I find out that x is 3. So what is the solution to this system of equations? It's 3, 3. That's the answer. I'm going to let you do number 3 on your own because it's fairly easy. The y is already isolated there. And I want to look at number 4 with you and one of the word problems. So number 4, when I look at these two equations, the second one is the one I prefer. So I'm going to just leave y where it is, take my x over, make it -x minus 2. So that's step number 1. I isolated one of the variables. I'm going to take it and plug that back into the first equation. So 2x plus 2, and in place of the y, I am substituting -x minus 2 equals 8. Don't forget to distribute the 2. 2x plus, or excuse me, well, I could say plus a -2x, because the negative here is going to make that negative, plus a -4. We'll just go ahead and be consistent with our parentheses. And those are going to cancel. Positive 2x, -2x makes 0. Wait a minute, -4 does not equal 8. What is going on here? That means that this is a no solution problem. What does it mean if it's no solution? It means that the two lines do not intersect. Therefore, they must be parallel. If we wanted to check that, take the first equation. If we divided everything by 2 and solve for y, let me change colors. So if I divide everything by 2, x plus y equals 4, then we isolate the y. That'll be y equals -x plus 4, and guess what? My screen went blank, but I got it back. So I'm back to y equals -x plus 4. Up, what's my slope? -1. What's my slope? -1. So they're parallel lines. But where do they meet? They will not ever meet. there's no solution to that system of equations. Okay, so let's tackle this first word problem. It says write and solve a system of equations. A nature center charges $35.25 for a yearly membership and $6.25 for a single admission. Last week it sold a combined total, that's yearly memberships and single admission, a combined total of 50 memberships. That's yearly memberships and single admissions. Now the total money was $660.50. How many memberships and how many single admissions were sold? So they were very nice and provided us this chart where we know X stands for the number sold. So we don't know how many yearly and how many single. We know that the total membership sold were 50. So our first equation is X plus Y equals 50. Now when you talk about the money, the yearly membership is $35.25. It's always about this time that I start resting my hand on the screen and making it mess up. And then $6.25 was for the single, and our total amount of money was $660.25. I think it's it doesn't like the pictures, the clip art is. So there are my two equations, and I need to solve. So step number 1 says to isolate a variable. I'm just used to isolating y, so we'll make that a negative x plus 50. And now I'm going to substitute that into my second equation. So 35.25x plus 6.25 times negative x plus 50, that's in place of y, equals 660.25. So just bear with me. You'll see the whole thing. There it is, the whole thing when I'm finished. So 35.25. All right, so 35.25x plus, and I have to distribute the 6.25 to the negative x, which makes it a negative 6.25x, plus, and then that's a positive 50, so 6.25 times 50 gives us 312.50. equals 660.25. All right, stay with me here. I don't know why my screen doesn't like me tonight. So it's going to be 35.25 minus 6.25. That's how many x's. So I have 29x. I'm combining like terms, these two x's together. And then technically I need to subtract 312.50 from 660.25 minus 312.50. All right, so that is going to give me 347, if I'm doing this correctly, 347.75. So let's come up here where we can actually see we have 29x equals 347.75, so I need to divide that by 29, and x turns out to be 11.99, which you can't have 11.99, so x is 12. We can't have 0.99 of a membership, so we round that up to 12. Okay, so we're ready for step number 3, where I'm going to take x is 12 and I'm going to plug it into where I've isolated the y. And so negative 12 plus 50 gives us a y value of 38. And that would be my solution. And I apologize that the screen keeps blanking out on us. I am so sorry. You try number 2 on your own, and it's a mixture problem. We did those at the beginning of the year. Now we're going to use what we know about systems of equations, and have a great day.